Everybody, it's Tyler here at the Purdue SIGBOT Slam and Jam event for VEXU teams check-in, which I think might be one of the coolest robots of the year that I've seen. It's PLATT3 PlattyPi coming in from UW-Platteville, and what makes this robot, or set of robots, so amazing, they're doing a Tier 3 buddy climb, where they literally climb on top of each other all the way up. It is absolutely wild, and we can't wait to dive more into this. A lot of great other stuff that goes in this robot. We talk about all the different materials that go into this, utilizing a ball shifter, and then going into a PTO for that climb as well, too, so great stuff with that. And we really diving, getting a great overview of what's all gone into this. So let's learn more about them coming up here on Pits and Parts. Nate, let's start diving into this drivetrain here. I mean, just a lot of cool custom work from your casted wheels, just all the materials that gone into this. Walk me through what's gone into your drivetrain.
Thank you, Tyler. So our drivetrain base is going to be a 8-motor, 600 RPM drivetrain. We use 1-to-1 gearing for all of our 2 Omni wheels and our 1 traction wheel, which is going to be 36 tooth gears. We do custom printed Omni wheels, so we can embed bearings directly into them to reduce as much friction as possible. And we also use custom poured traction wheels here, which give us about almost like a 25-pound pushing force, which maintains a lot of integrity on the field, makes sure we cannot get pushed around and can maintain goal control.
And earlier, when you were in a match, you got kind of in this little bit of tug of war, right? And you guys were just absolutely dominating, I think, the other robot during that. So really cool. When you were looking at your wheel config, was this the first config you came up with, or did you have other ideas?
We started off with a 600 RPM drivetrain because we knew we wanted a very fast drivetrain, because we knew we were going to go with a pretty heavy robot.
Sure.
So to be able to move pretty fast. So we started with a 600 RPM, kind of evolved, just kept it because we realized it worked pretty well. We did swap to a mostly flat traction wheel here because it helps us with the most grip. We did slots before, but that was really used to displace water, which I guess doesn't really help in VEX unless water games sometime, but that's never going to happen.
Know.
So yeah, we kind of stuck with 600 RPM. Worked pretty well for us.
How much do these robots weigh?
They weigh about 24 pounds. Definitely a hefty robot,
yeah.
But with as much that goes into it, I would say it's definitely worthwhile.
They're big boys for sure, right? So let's pass over to Jackson, talk about the material that's gone into this. And we were talking earlier, just a lot of custom work, not using too much C channels, a lot of great different custom materials. So walk me through what you're using.
Yeah, so our primary base is 3D printed PLA from Polymax. It is the basis of pretty much anything we do. If it doesn't need to be incredibly special in some certain property, it's going to be PLA. Otherwise, if we want a more flexible piece, we'll use TPU. I believe we get it from Hatchbox. It's incredibly flexible, and it allows rings to slot right in, just as we need. We also use it on our intake here, where we are allowed to basically go in, and it will stop them from popping out at any time. Then we also use on the back of the robot these carbon fiber pieces that these pieces would absolutely break if they were not carbon fiber, if they were just PLA. And we've had multiple sets across the time break using them. Other than that, the last major material we use is Delrin plating, as it's so much lighter than aluminum, but maintains integrity.
Can we turn this robot around? I got to ask you about these cat ears on the front here. The one they're completely adorable, but two, are these just used to keep the rings in, like when you're doing intaking?
So when we feed the ring in here, we had a major problem where the ring would just kind of come out, but with the cat ears here, it allows us to have some give on them with the hooks, but not have any form of push out.
A lot of great stuff that's gone into this. We got to pass this over to Ethan, though. I'm so excited to discuss this on your guys' robots here. Is just what's gone into your whole lift mech into this buddy climb, and all this integrates together. And then, of course, we'll be showing it on the practice field a little bit later, too. So just walking through on just how you even came up with all this and what it's all comprised of.
Yeah, absolutely. It definitely took a while to get to the point where we are. We've gone from a corner climb where the robot grabs onto the other robot out here and just one climbs, to doing the same on the side, to a couple other things, and finally we ended up on this. Essentially the way this works is we have this can go up, we have hooks here, they're able to flip like that, as well as down here. These ones don't move, and these go up with the lift. And so you'll see both of them have essentially the same set of things. If you could run the lift up real quick here. So you can see these hooks go up, essentially they grab onto the ladder, and then these static hooks end up sitting right on the other robot's hooks. That is one minor difference between the two bots, otherwise they're mostly identical. And they're able to just slide up along here very smoothly, allowing us to get all the way to tier 3. And the really cool part about this is that it's a buddy climb, because you can see here, we're resting on the other robot. The orange robot is only resting on this blue robot's hooks, and the ladder bar sits right in here. It never actually touches either robot. It is very close, but there's no chance we're going to touch the ladder while climbing.
How do you know when you're aligned correctly, when you're getting ready to climb? Like, what's the indicator you're exactly in the right spot? Because you don't have a lot of tolerance in that.
Yeah, so it is very interesting. That's one of the things we're still trying to improve, but honestly, in the matches where we've climbed so far, it's seemed relatively easy. Essentially, if we get them within quarter inch to half inch of each other, we just make sure out here, these two Delrin plates are relatively in line with each other. If so, then it seems like we're going to be good most of the way up.
This is so just incredibly exciting to see. I love the innovation that has gone into this, and you know, when you look at what a challenge it is too, I think that's one of the great things in VEXU is you really get to tackle the engineering challenge of it itself in a whole new way as well too. So looking back at it right now, would you do this any other way, or are you really happy with the product you have so far?
I'm really satisfied with this product we have so far. There's absolutely some iterations that still needs to go through. This was a little bit rushed trying to get ready for Purdue, but now we're going to have quite a while until our next tournament, so we're going to be able to refine this thing, get it working real fast. Gonna slide in here. He's gonna go on first. I'm gonna go on right after him, lined up pretty well. And now I'm gonna engage our PTO mech. Was not quite engaged there. Let me go again. Is that good? Perfect. Engage PTO, there we go. He engages PTO, both pulling up. He's gonna go all the way up first and get his static hooks on. I'm gonna follow right after him, get my static hooks on, get my next hooks going up. He's getting his hooks on underneath. Now this is the one thing that might not work, might need a little help pushing those hooks into alignment. There we go. And I start pulling my way up. He has the same right here on 3, 2, 1, go. Synchronize that so that we don't die. Leave. All right, am I good? All right. I'll go up. All the way up. He's going all the way up. Same exact cycle as before now. He gets his hooks on. To try flipping my arm out. Is that enough? Little. I can't bring my arm any further out right now. I want to give it a little nudge. Yep, there we go. All right, now you start pulling. You can start pulling as well. Struggling a little bit here. Got it over. All right, 3, 2, 1, go. All right, do you want to go down? Get your static hooks on. I'll go over. Both of mine are on. And that right there is a tier 3 double buddy climb. First I've ever seen.
As we start wrap up, let's pass over to Braden and walk through a couple other last attributes of this robot as well. This is just everything, and this is so gorgeously packaged. What do you want to wrap up on?
Okay, so to really make our arm different than everybody else, we have a a chain bar, if you can toggle it back. And we have four different state positions. We have a store position, a low position, and a holding position, if you hold it up, and it goes back down at the end. We make sure it goes down at the end so it can really score on the wall sticks very effectively, and you can sit underneath, you can lift it up, and it will drop it right back down all at the same time. So it makes it really easy, and then you can just sit there at the end to guard the stake, or you can double back up and go for another one.
PLATT3, we can't wait to see, as you mentioned, another event later on coming up, so we can't wait to see those continued improvements happen on this. But I think as this is an incredibly inspirational set of robots here. So congratulations on putting all this together. We can't wait to see how you do throughout the rest of the season, and hopefully still hoping for a berth in VEX Worlds as well too. So good luck the rest of the way, and we can't wait to see more of your team later on.